Question 1. Jody wants to buy 3 objects. She first of all wants to buy a bow and arrows, which is 60 coins. Then she wants to buy a shield for 80 coins, and finally a sword for 90 coins. All right, so in total, that gives us 60 plus 80 plus 90 equals 230 coins. We know that Jody currently has 35 coins, so she really only needs 230 minus 35, which is 195 more coins, in order to be able to afford what she wants. Now the question asks us, what's the smallest number of puzzles that Jody will need to be able to solve to buy all 3 objects? And when it says smallest, that gives us an indication that we're going to go for the most efficient way of earning coins, which is to solve difficult puzzles. An easy puzzle only gives 10 coins, whereas a difficult puzzle gives you 15 coins for each solve. So we're going to go with the difficult puzzles. So here we go. We're just going to divide 195, which is the total number of coins, by 15, which is the number of coins per solve. And that's going to give us 13 puzzles. So therefore, Jody needs to solve 13 puzzles to be able to buy all 3 objects. Answer option B. Moving on to question 2, here we have a pretty classic deduction question where we're going to put some people in order on a line. Just glancing through the 4 pieces of information that were given, we have the first and fourth pieces of information that kind of stick out to me because they both involve the Jara person, whereas the other ones are kind of all over the place. So I think a good way to start is by looking at the first and fourth pieces of information. So looking at the first, we have Jara is sitting immediately to the left of Ali. Okay, so we're just going to put that down. Jara is immediately to the left of Ali. By the way, immediately just means that no one is there in between them. So we're going to put them fairly close together. The fourth pieces of information tells us that Jara is sitting on one end of the line. All right, so one end is either the left or the right end, but clearly in this situation, Jara is not going to be sitting at the right end because he's already to the left of someone else. All right, so Jara is definitely going to be at the left end of the line. Okay, so with that established, let's move on to the second piece of information. Daniel is sitting immediately to the right of Nala. Okay, we're just going to pop these 2 people down to the right of the first 2. Just keeping in mind that the reason we put them to the right of them is because Jara's at the very left end of the line and Ali's just literally immediately 1 spot to the right of Jara. Okay, so with this completed, we're going to go on to the third piece of information that Jessica is sitting next to Daniel. We're going to pop Jessica to the right of Daniel. Remember, Jessica can't be to the left of Daniel because Daniel is immediately to the right of Nala. No one's going to come in between those 2 people. So Jessica has to be on the right. Okay, looking at the question, it says, who's sitting in the middle of the line? Well, that's going to be Nala. And answer option C is correct. Moving on to question 3. Anyone who helped Mr. Bamblet with the school garden last week will be given a ticket to the country fair at the weekend. And we've got Catherine who says, that's great. I helped Mr. Bamblet with the garden last Thursday, so I'll definitely get a ticket. Yeah, that's pretty straightforward. That's a fairly easy question where it kind of suits the information given in the passage or the prompt. It says that anyone who helped will be given a ticket. And since Catherine helped out, she will be given a ticket. So yes, Catherine is correct. Let's look at what Kylie says. Fran told me that she's going to go to the country fair. She must have helped out too. Well, this actually is incorrect. Just because Fran got a ticket, it doesn't really necessarily mean that she got it by helping out with the garden. She definitely could have got it through other means. For instance, she just happened to buy it herself with money, or she helped out someone else that's not the garden. Not to say that she didn't help out the garden, maybe she did, but we just don't know that and we can't come to that conclusion. That's why Kylie is incorrect. All right, so summarizing this, Catherine is correct, Kylie is incorrect. We're going to go with answer option A. Question 4. Okay, so we've got 2 receipts over here, and if we have a look at the question, it asks us how many lollies did Madison buy? So that's kind of our cue to look at lollies specifically without focusing on chocolate bar, lemonade, milk, whatever other things are in here. So we're going to go with lollies. First of all, we can work out that 1 lolly costs $1.60 divided by 2, which is 80 cents. Reason being that 2 lollies cost $1.60. So naturally, 1 lolly costs 80 cents. Okay, now that we know the price of a lolly, we're going to try to match that price to one of the rows in the second receipt. The premise of the question is that we don't know the identity of the items in the second receipt, but we can match it with that of the first. So if something costs 80 cents, we know that it's going to be lollies. So again, we're going to have to figure out the cost of one particular item. In the first row, 3 items cost $2.10, meaning that one item costs 70 cents because we divided $2.10 by 3, which is 70 cents. That's not quite what we need. We need 80 cents, remember? Okay, so crossing that off. The second row, okay, 2 items cost $2.40, meaning that one item costs us $1.20. Again, that's not quite what we need. Let's move on to the third row, where 4 items cost $3.20. Bingo, $3.20 divided by 4 is 80 cents, which means that the third row represents lollies. So if we just look at the quantity of items in the third row, it says 4. So that means that Madison bought 4 lollies. Answer option D. Question 5, again, we have a deduction question, except this time it's a little bit trickier. So if we read the first piece of information, it tells us that Blue is the youngest turtle and Lil, L-I-L, is the oldest turtle. And this piece of information actually runs on to the second one, where it refers to the youngest turtle and the oldest turtle without actually telling us the name that, the youngest turtle is Blue. I think it's done that to make things a little bit complicated for us, but that's all right. If we're doing the paper version, we can literally just write over it. So cross out youngest turtle, replace it with Blue. Likewise, we're going to replace oldest turtle with Lil. So overall, the second piece of information should read that the turtle known as Eve arrived just before Blue and half an hour ahead of Lil. Okay, the third piece of information says the turtle known as True arrived a few minutes after Blue. Alrighty. Okay, so in this case, we're going to start off with the second piece of information, simply just because it has, it gives us a definite position for 3 turtles already. Okay. The second piece of information shows us that Eve arrived before Blue, who arrived before Lil. So here we go. And that, by the way, that's assuming that the left side arrived earlier and the right side arrived later. Keep in mind here that when it says half an hour, that's going to be longer than an instant, which is implied by just before. The first piece of information also confirms that Blue arrived before Lil, which we can kind of tell through the second piece of information anyways. Okay, moving on to the third piece of information, it tells us that True arrived a few minutes after Blue. We're going to insert True over here. The reason we do this is because we know that True arrived before Lil. This is because True arrived only an instant and a few minutes after Eve, whereas Lil arrived half an hour after Eve. Half an hour is definitely going to be longer than the sum of those few minutes and literally an instant. Okay, so if we piece all of these information together and we get a final order, we can see that Blue arrived second. So answer option A. Question 6. we've got an argument question. The premise of the argument is that we should ban videos of pets getting harmed because the owners are intentionally sacrificing their welfare to get views and attention, which seems really cruel and just a wrong thing to do. But we will kind of try to weaken this argument by showing that not all funny videos were made deliberately, with the owner actively trying to actually harm their pet for views. Sometimes it's possible that a funny event just got caught on camera by chance, and in that case, it seems totally okay to post it for, for humor. The key lies in the fact that the owners weren't deliberately trying to do this, as suggested by the argument, where it says the desire of their owners, as if they're intentionally doing this. So answer option A is correct. Moving on to question 7. All right, we've got 8 competitors taking part in a series of 6 challenges. The table below details the results of each of the challenges, and we've got a whole heap of names to take in. The key to this question is not to get fixated on reading all of this. We're just going to move on to the question. Who was the only competitor who was ranked in a different position in each of the 6 challenges? And I think one of the big takeaways from this question is that sometimes trial and error is very useful. We're not going to go through Luke, Dawn, Zara, Adam, Jade, every single person involved and see what their rank is, because that would be quite a big waste of time. Instead, we're going to have a look at the answer options and just go by that. There's no need to examine every single person. All right, so let's look at answer option A, Dawn. That's incorrect because Dawn placed 8th in both the first and the 4th challenges. So he did not satisfy the requirements of the question, which was to rank in a different position every time. Moving on to answer option B, Evie. Again, that's incorrect because she placed 2nd in both the 3rd challenge and the 6th challenge. Moving on to option C, that's also incorrect because Jade placed 5th in both the 2nd challenge and the 5th challenge. Now that leaves answer option D, which is correct. In the test, it may not even be necessary to confirm, but since you already know A, B, and C are incorrect, but we will go through this just for the sake of completeness. Option D is correct because Theo was ranked 7th, 3rd, 5th, 2nd, 6th, and 4th in the 1st, 2nd, 3rd, 4th, 5th, and 6th challenges respectively. Okay, moving on to question 8. Zoe's going to a party this weekend and most of the children in her class will be going as well. Zoe says, I will know most of the people at the party because they're in my class. Okay, which of the following sentences shows the mistake that Zoe has made? So the core mistake that she's made is thinking that no one else is going to show up other than the people in her class. By her logic, she probably thought that the number of people is probably going to be quite similar to the number of people in my class because only my classmates are going. And since I know most of my classmates, then I will know most of the people at the party. But the reality is she doesn't know how many people is going to actually attend. Let's say that there's 30 children in the class, but 200 children got invited. And all of those other 170 people she doesn't actually know. Well, in that case, she's not going to know everyone there. Actually, she's got to know quite few people there if we think about it. 30 divided by 200. Okay, so answer option D is correct, where it says a large number of people might be invited to the party. That accounts for the fact that there might be other people joining the party that she doesn't know. Question 9. Asha, Drashti, Jason, and Jenny were all born in the same year but in different months. Asha's older than Jason, and Asha's younger than Jenny. Drashti is younger than Jason. And it says, given the information above, which one of the following cannot be true? Okay, so I think first of all, we actually need to order the people from oldest to youngest. So we'll say that the left side is older and the right side is younger. All right, so Jenny is the oldest. So she was born in the earliest month. Asher, Jason, and Drashti were all born in later months than her. Note that they're all born in different months. So let's look at option D, where Jenny was born in November. That's actually impossible, because if Jenny was born in November, then Asher would be born in December, because remember, Asher is younger than Jenny, so he's going to be born in a later month. Now, okay, so Asher is born in December, but what about Jason and Drashti? They're literally, there's no option for when they're going to be born, because they're going to have to be born later than December, but there is no month that's later than December. Option D gives us an impossible scenario, so option D is correct. Question 10, a little bit of a tricky question, but we have a pencil holder here, which is shown below, and which one of the following shows a side view of the pencil holder? Option B and D are, both of them look correct, but only option B is correct. And we're going to first of all go through why option B is correct. Then we're going to understand why option D is actually incorrect. All right, so if we look from the left of the object, the pencil holder, we can see that option B is correct. I'm going to attach an image over here, labeling 1, 2, 3, and 4 for each of the corresponding faces, so that you can see clearly which face corresponds to what on the view. Okay, we're going to go on to why option D is actually incorrect. Most of the features in option D are actually correct. However, a line over here exists when it shouldn't really exist. By the way, this is looking from the right view, as we can see in this image. So this line doesn't exist in the actual image, in the actual pencil holder, but somehow the line exists in the view. So that's why option D is incorrect. Question 11. You can only go on the ride at the theme park if you're at least 12 years old or you're with an adult. Okay, so straight off the bat, I think it would be useful if we went through 4 different scenarios that might happen. Okay, so scenario 1. What if you're less than 12 years old and you're not accompanied by an adult? Well, in that case, you can't go on the theme park because you don't have either of the 2 conditions. That's actually the only way you wouldn't be allowed to go on the theme park. Let's look at 3 other scenarios. Okay, so scenario 2. What if you're less than 12 years old, but you're accompanied by an adult? Well, in that case, you are allowed to go on the theme park because you have an adult with you. Let's look at scenario 3. What if you're more than 12 years old and you're not accompanied by an adult? Then you actually can go on the theme park because you're already more than 12 years old. And scenario 4 is if you have both conditions. So basically, you're older than 12 years old and you're accompanied by an adult. Well, yes, of course, you can go on the theme park. You have both conditions satisfied. So what we can take from that is there's only one scenario where you actually are not allowed on the theme park, is if you're both less than 12 years old and you don't have an adult with you. Anything else, you can go on. Okay, let's have a look at the 2 people and what they say. Robbie says, Bindi just went on the ride with her father, so she must be less than 12 years old. That's actually incorrect. If we think back to the 4 scenarios that we've kind of plotted out in our heads, if we look at scenarios 2 and 4, we can see that if Bindi is accompanied by an adult and went on the theme park, she's either less than 12 years old or over 12 years old, so we can't draw any conclusions. Both ages are fine and both will allow her to go on the theme park. Remember, the only way someone would be declined is if they're younger than 12 and they're not accompanied by an adult. If she already has an adult, so her father with her, then she could be either one of 2 things. She might be older than 12 or she could be younger than 12. We literally just have no clue and no idea. So Robbie cannot draw that conclusion. She's incorrect. Let's look at what Cohen says. Cohen says, but Nicole was on her own on the ride, so she's at least 12 years old. Yes, that's correct. So from scenarios 1 and 3, we can see that if someone is not accompanied by an adult, the only way they can go on the theme park is if they're at least 12 years old. Otherwise, she would have been declined. So summarizing, Robbie is incorrect, but Cohen is correct. So we're going to go with answer option B in question 11. Question 12 is a deduction question. And again, here it's actually a really good idea to trial and error. Looking at answer option D, a team cannot be formed if Lachlan is on it. Cannot be formed in the sense that there's literally not enough people to join the team if Lachlan's in it. The reason being that Lachlan and Cecil can't be on the same team. So Cecil is definitely off the team. It also tells us that Prash can only be on the team if Cecil is. So we know that Cecil's off the team. That means Prash is also off the team. There's only 2 other players that are left to add on to the team with Lachlan. That's only a 3-man team, not a 4-man team, which is the full thing that we are required. So Lachlan cannot be on the team. Answer option D is correct. Question 13, we have a bit of an algebra question. The most difficult stage, if we already know how to solve and use algebra, is actually allocating the variable of interest. So do we want to say let D equals the number of coins that Dom has, or do we want to say B equals what Bailey has, or do we want to say another variable, like for instance E for Ella? Now the key to this is actually glancing through all the different pieces of information that were given and selecting the one that has most ties with all the other people. And in this case, it happens to be Ella. The reason being, if we look straight up at the second and fourth pieces of information, it already involves Ella, where Bailey has 1 more than Ella and Dom has twice as many as Ella. Now we might be thinking, what about the first and third? Well, we can actually relate those to Ella as well. Look at the first piece of information where it says that Dom has 1 more coin than Annie. Well, we know that Dom has twice as many as Ella, so Annie technically has 1 less coin than twice of Ella. And the same thing for the third piece of information, where it says that Callie has twice as many as Bailey, and we do know how many coins Bailey has in terms of what Ella has. So let's proceed and say that Ella has E coins. Okay, so Dom has twice as many coins as Ella, so he's got 2 E coins. Bailey has 1 more than Ella, so he has E plus 1 coins. Now Callie has twice as many as Bailey, so he has 2E plus 2 coins. Finally, Annie has 1 less coin than Dom, so she has 2E minus 1 coins. And altogether, if we add up what everyone has, we have Ella, who's E, plus 2E, which is Dom, add on E plus 1, which is Bailey, add on 2E plus 2, which is Callie, and then add on 2E minus 1, which is Annie. And collecting like terms and kind of getting this whole mess together, we get 8E plus 2 coins. We also know that these 5 friends have 26 coins in total, so we can actually form an algebraic equation from this, where 8E plus 2 equals 26. We're going to subtract 2 from both sides, 8E equals 24, and then we're going to divide both sides by 8, giving us E equals 3. The question doesn't end here. It says, which one of the following has 4 coins? Okay, so Ella clearly doesn't have 4 coins, she has 3. But who has 4 coins? Well, Bailey does, because Bailey has E plus 1, which is 3 plus 1, which is 4 coins. Answer option B is correct. Moving on to question 14. The premise of this argument, her grandfather's argument, is that using an app, a plant identification app on the phone, won't help someone become a good gardener, because all good gardeners need to recognize plants without any external or outside help. Now, we're going to weaken this argument by showing that you don't actually need to do this to be a good gardener. You don't need to be able to recognize plants without any help at all, just to be a good gardener. Because the fact is, if we looked at answer option D, where it says if this is true, it most weakens this argument. Well, if the answer option D is true, then experienced gardeners or good gardeners often use books to help them identify plants. So even those really experienced and great gardeners use outside help in order to identify plants. So this weakens the grandfather's argument that that you need to be able to recognize plants just by looking at it in order to be a good gardener. Moving on to question 15. Ray says, if they gave Tony's class ukulele lessons for a term, they would probably get on with each other better. Now, that's true. Yeah, that seems true, because in the question stem, it says that actively listening and working with others help them interact with each other a bit better, than referring to children who are exposed to music, for instance, the ukulele. Note that Ray uses the word probably, which is really important here. If Ray said something like they would definitely get on with each other better, that may not be even correct. But here he says probably, which means that the statement is a lot likely to be correct, because it's not a strong statement that requires hard and solid proof to actually be correct. He just said probably, so it's not a 100% type of thing that he's claiming, and so Ray is correct. Now, this is actually directly opposite of Juan Pablo, who says it's not possible to give ukulele lessons to the whole class. That would mean that some of them will never learn to get along, with the focus on never. So Juan Pablo is using a very strong word in never. This means literally zero. So if he does make that claim, he's going to need a lot more solid, hard proof to back his statement up. And unfortunately here, it seems like there's no such proof in order to prove his statement. And also, the premise of what he's saying is never suggested in the stem at all. So Juan Pablo is incorrect. If we summarize everything, Ray is incorrect, Juan Pablo is incorrect. Ray is correct. So answer option A is correct. Okay, moving on to question 16. We've got 5 dominoes and 2 dominoes are shown below. So here we are. Sunny joins his dominoes end to end. So those two can be seen on the end, such that 2 numbers on the touching faces of adjacent dominoes are the same. He puts the 2 dominoes shown above at the ends and 3 others in between them as shown. And the question asks us which could be the 3 dominoes shown above as blank. So here we go. Here's the solution. And we can see from this that option B is correct if we just rearrange the dominoes a little bit. Moving on to question 17. In this calendar, this year is divided into 6 seasons like this. And it looks like it's given us a little bit of extra info, hot and dry, wet, becoming cool, etc. I think this seems a little bit redundant and it's there to throw you off. So, looking at the question, my sister's birthday occurs in the season after my birthday. However, our birthdays are almost 6 months apart. Okay, so first of all, here we're going to make things a little bit simpler. We're just going to draw a timeline from January to December. These are our months, but we're also going to include the seasons from this calendar as shown. Okay, the key to this is that where our birthdays are 6 months apart, but only 1 season apart, so consecutive seasons. And if our months are something like August and December, that actually spans across many different, like 3 seasons. So June and December, which is 6 months apart, 1, 2, 3, 4, 5, 6, and yeah, that spans 4 different seasons. So that's clearly not going to work. The reason being that these seasons are actually too short. So what we're really looking for is very long seasons that are next to each other, such that the seasons next to each other have a total of 6 months. And we can indeed see this in the beginning. So January, February, March, which belongs to Buran, and April, May, and June, which belongs to Marigang. So I am born in January, and my sister is born 6 months later, almost 6 months later, in June. So she is Marigang. Answer option B is correct. Moving on to question 18. Some people think that being brave means not being afraid of anything, but this is wrong. Okay, and what is right then? Well, it says that a brave person is someone who does whatever they need to do, even if they do feel afraid. Okay, so a big condition. If they feel afraid, they can still do it. Let's look at what Xin Yi says. She says that Simon's afraid of flying, but he got on the plane anyway because there's no other way to visit his grandparents. He must be a brave person. Well, yes, that is correct. Simon fits the definition of a brave person as given in the question stem because he's doing what he needs to do, which is to get on the plane, even if he feels afraid, which he does. Let's look at what William says. He says that actually anyone who gets on an aeroplane must be brave. Well, remember here, a key part of this question is not using our own opinions or knowledges. Instead, we have to look at what the question stem says. And the question stem says that they need to do whatever they need to do, even if they feel afraid. Now, some people might not actually be afraid of aeroplanes. Some people might think of it as just a normal activity. So are they brave or not? Well, we don't really know because they're not afraid. So how are we going to make a judgment of if they're brave or not? So William can't actually make this statement if he is actually incorrect in making it. So Xin Yi is correct, but William is incorrect. Answer option A is correct. Let's look at question 19, where it says that James and 4 of his friends are collecting from the same set of cards. Now, the cards are normally sold in packs of 15 for $10 each, but the shop sells 3 of these packs for $25. So 3 packs, that would mean 45 cards for $25. All right, James and his friends each have $20. So they decide to put the money together and buy as many packs as possible. Then they will share their cards out equally among themselves. The question asks us, how many more cards does James get by buying them with his friends rather than buying by himself? So there's 2 components to this question. First of all, we need to figure out how many cards he gets by buying it by himself. Then we need to compare that with the scenario that he buys it with his friends, and then do a final calculation or subtraction. Let's start off with assuming that James is going to buy cards for himself and by himself. So he has, how much does he have? He has $20, as does all of his friends. So with that $20, he can buy 2 packs of 15 because each pack of 15 is being sold for $10. So if he buys 2 packs of 15, he's going to end up with 30 cards. Now let's consider the scenario that James buys cards with his friends. Together, they are 5 people, so they're going to pull together 5 times 20, which is $100. The shop is selling 3 packs of 15 cards for $25, and they're going to take this deal 4 times because $100 is 4 times $25. Remember that 1 pack actually contains 15 cards, so in that deal, each time they take the deal, they're going to receive 3 packs, which is 3 times 15, which is 45 cards. Now, since they took it four times, it's going to be 4 times 45, which is 180 cards. So together, they receive 180 cards. Now, James only gets a fifth of that, which is 180 divided by 5, gives us 36 cards. So therefore, we can see that James gets 6 more cards if he buys it with friends, because 36 minus 30 equals 6. Answer option B. Moving on, question 20. She's been listening to the radio and she says that the weather forecast says we're in for a very hot spell. I don't think it's going to be as hot as last December though. Last December was the hottest December ever. So it's pretty unlikely to be as hot as it was back then. Now, it's asking which statement weakens this argument. Well, the argument, first of all, is based on the premise that since last December was the hottest December ever, which is a record temperature, it's going to be unlikely for this December to be just as hot. I mean, who's to say that records are continuously broken, right? But we will weaken this argument by showing that actually it does make sense for records to be continuously broken if we're given the fact that over the last 5 years, temperatures have been steadily rising. This explains why last December was the hottest December, because it was steadily rising. And furthermore, it also suggests that next year is going to be even hotter if we follow this trend. Keep in mind, this isn't to say that this is a 100% chance or a definite thing, or definite occurrence, but it does kind of weaken this argument because it shows that there is reason to believe that it's completely possible for this December to be just as hot, if not hotter, than last one. Question 21. Okay. This is a fairly long stem, but the logic of it is quite simple. It's just that the tunnels are always open 24/7 hours a day, 7 days a week. This is most of the time. However, the only time when it's actually closed is if it's raining very heavily, and it provides a long reason as to why this is, which we don't need to be concerned about if we want to save time. So the key logic is that it's always open unless it's raining, essentially. All right, let's look at what Amelia says. My mother told me that she couldn't drive through the tunnels yesterday evening because they were closed. It must have been raining. Yes, that's correct, because as we said earlier, the only time it's ever closed is if it's raining. It's closed right now, hence it's raining. So yes, that is logically correct. Amelia is correct. Moving on to what Sheng says. It's not raining right now, so the tunnels will be open to drivers. Yes, it's correct. If we look at the statement, otherwise the tunnels are open. Well, yeah, so if it's not raining, the tunnels will be open, which is exactly what Sheng says. So both Amelia and Sheng are correct, which gives us answer option C. Question 22. Here we have a deduction question, a kind of a guess the letter game. Right, so Zig thinks of a secret word, which May tries to guess. Now we can see that May takes 3 guesses over here: flood, crown, and bread. To each guess, Zig replies with 5 symbols. Plus means that the letter's in the right place. Hashtag means that the letter is in the word, but it's just in a different place. Whereas minus means that the letter's not in the secret word at all. The easiest way to go about this question is by process of elimination. It's going to take too much time if we try to work it out straightforward, like forward, but it's actually a lot easier if we use elimination method. So here we go. Let's look at the first guess, flood. Zig replies that there's a plus in the second position, so there is an L in the second letter. Now, straight off the bat, we can cross out option B because the second letter is R, not L. And in the flood guess, we can also see that there's a minus sign for the third and fourth positions, which correspond to the letter O. Now, this means that O is not in the word at all. However, answer option A has the letter O in it because clown has the letter O. So we can also cross off answer option A. Now finally, let's have a look at the guess crown. We can see that the letter N is not going to be in the secret word because there's a minus in the last or fifth position, which corresponds to N. Okay, and we can eliminate option C from this because clean has the letter N in it. This leaves option D, which is correct. Moving on, question 23. Horses have eyes on the sides of their heads, which means they can almost see all around them all the time. We think they evolved this way because they are prey animals. and a wide field of view makes it harder for predators to sneak up and eat them. Now we've got Lana, who says that chameleons must be prey too because they also have eyes on the sides of their head. Now Lana's made a really big mistake in saying this because you can't say that the reason that horses have eyes on the sides of their heads is exactly the same reason that chameleons do as well. In reality, there may be other reasons for non-prey animals to have eyes on the sides of their heads. For instance, a predator might have eyes on the side so that they're more aware of where their prey is running and they can see all around their surroundings to figure out the best way to capture prey. That's just one possible reason. So the key here is that Lana can't draw this conclusion that chameleons are prey as well just because they have eyes on the sides of their head. Answer option B is correct. Let's look at question 24 now. So we've got 4 friends who are standing together, and each of them is going to make a different statement about how many people are lying. So Aaron says 1 of us is lying, Bridget says 2, Caitlin says 3, David says 4. Now the key to this question is that 1 of these people are actually going to be correct. Because there's only 4 people, it's either 1 person or 2 or 3 or 4 people who are lying. So 1 of them definitely got it right, but the other 3 are telling lies about how many people lied. So based on this information, that this kind of insight that we just gained, we can tell that Caitlin is the one who's telling the truth. Caitlin says that exactly 3 of us are saying something false. So yes, like we just said, 3 people are lying about the number of liars. So Caitlin must be telling the truth. Answer option C is correct. Moving on to question 25. We've got a couple of tourist attractions here, and we've got a nice little map showing us the distances between each attraction. It says Eleanor wants to see as many attractions as possible, starting from the cafe. She visited 4 other attractions before returning to the cafe. She traveled a total of 50 kilometers, and it asks us which of the following did Eleanor miss out on. Okay, so the first thing that stands out a lot to me is the 5 km and 15 km. The reason being that all of the other distances are 10 kilometers. We know that she travels a total of 50 kilometers. So let's say for a second that she used the 5 km path, but she didn't use the 15 km path. Now that's actually very problematic because we'll never get 50 kilometers, even because everything else is just 10 kilometers, and she's going to add on an extra 5. So the end digit of the total distance is going to be 5, not 0 like we need. So the takeaway from this is that if she takes the 5 km path, she's going to definitely also use the 15 km path. Likewise, if she uses 15 km, she must also use the 5 km. This is because you can add them together to get 20 kilometers, and kind of if you were able to piece 50 kilometers, that's how you would do it. So let's have a look. How do you piece 50 kilometers with both of these? That's assuming that she does use both of them. So let's go from cafe to tower. That's 10 kilometers already. Let's move to aqueduct, which is 5 kilometers. So that's 15 now. We're going to move to lake. That will give us 25 kilometers. And then move down to marina. So you add on 15, which is 40 kilometers. Now we're kind of stuck here because we can't go back to cafe without using 60 kilometers. So what we can understand from this hypothetical was that she actually doesn't use 5 km or the 15 km. She only uses 10 km paths. She can do this by actually traveling from cafe to tower to lake to aqueduct to beach, then finally back to the cafe. So here's the path over here. And we can see that Eleanor misses out on the marina, which is why answer option C is correct. Moving on, question 26. It says that the deadline to complete the geography homework was last Friday. Anyone who didn't complete it on time will have to stay behind after school tomorrow to finish it off. We've got Kalinda over here who says, I know Abby didn't hand in homework on time, so she'll definitely be staying behind tomorrow. This is fairly straightforward. It's quite simple. She's definitely correct because this is basically repeating what the question stamp is saying, that anyone who didn't complete it will have to stay behind, and Abby falls under this category, so she'll stay behind. Okay, Kira. Kira says that Lottie has to stay behind tomorrow, so she must have failed to complete the homework on time too. So she's using the fact that Lottie's staying behind to draw a conclusion about why she's staying behind tomorrow. Now, she can't actually draw this conclusion because there's a lot of different reasons why someone may have to stay behind tomorrow. We know that if you didn't finish homework, you have to do it, but there's also other scenarios where you might need to stay back. For instance, what if someone has a couple of extracurricular activities that they want to do, or if they stayed behind just because their parents were late for pickup. So this is why Kira is incorrect. She cannot draw this assumptive statement. So Kalinda is correct, Kira is incorrect. We're going to go with answer option A. Question 27. Elise has a set of letter cards, one for each letter of the alphabet. Each letter card is either red, green, or blue. Now, she makes the words cat, dog, dot, bit, and rat, and notice that each of these words use all three colors. And the question asks us which one of the following words would also use all three colors. The key to this question isn't trying to figure out exactly what each letter card actually is colored, because that would be near impossible or impossible. Instead, we need to compare the different words to one another and draw conclusions from these comparisons. So I'll start us off comparing cat and bat. So we know that both of these words use all three colors. A and T represent two different unique colors, whereas C and B both represent the leftover color, the exact same color. The reason being that there's only three colors to begin with, and A and T are both used in these two words, so the remaining letters in both of them, so C and B, must be the leftover color, so exactly the same color. Okay, now that we know that C and B are the same color, we can eliminate answer option C, because it has both of these letters C and B in the same word, cab. So using the same principle, we can also compare dog and dot. D and O are colored exactly the same. Sorry, D and O represent two different colors, whereas G and T are colored exactly the same because they represent the leftover color. So from this, we can eliminate answer option D because it has both T and G, which are the two cards of identical color. Finally, we can do this one more time, comparing bit and bat. Okay, so both of these use all three colors. B and T represent two different colors, whereas I and A both represent the same leftover color. From this, we can eliminate answer option A because it uses both A and I in the word aid. And A and I, as we know, are colored exactly the same. So therefore, answer option B is correct. It's the only leftover one. Question 28, we've got a graphs question. All right, so in this question, the best way to approach it is by trial and error. So let's have a look at answer option A, Andrew. Now, this is incorrect because Andrew, in the table, it says that Andrew scored higher in English than in science. He got 32% for English, whereas he only got 28% for science. But this isn't reflected in the graph. In the graph, the English bar is lower than the science bar. So the graph definitely doesn't belong to Andrew. All right, moving on, let's look at answer option B. That's also incorrect because in the table, it says that Bryony scored the same in history as in geography. So she scored 38% in both subjects. But this isn't reflected in the graph either. So in the graph, the history and geography bars are not the same height. Moving on to answer option C, which is also incorrect. Charlie scored higher in history than in science. But this isn't present in the graph because the history bar is actually lower than the science bar. This leaves answer option D, and all of the data is correctly shown. Question 29. Chris and Lily were both setting up dog walking services in their local areas. They discovered three things. First of all, the more people who know about their services, the more people are likely to use them. Second of all, if no one knows about them, then no one will use them, unfortunately. The third thing that they've discovered is that if they put leaflets in people's houses, then more people will know about them. Okay, so what does Rosie say? Lots of people have started using Lily's service recently. She must have been leafleting houses. All right. Now that's incorrect. The reason being that just because lots of people have started using Lily's service recently, we don't know how this change was brought about. It doesn't mean that she was putting leaflets in people's houses. That's completely possible. I mean, she may have done that to increase popularity of her service, but that's not a conclusion that we can draw. There may also be other things that she did. For instance, putting up TV advertisements or something like that. So Rosie can't draw this conclusion. Let's look at what Ryan says. No one's been using Chris's service, so he can't have been posting any leaflets at all. Now, that's also incorrect. Just because no one has been using Chris's service, it doesn't mean that no one knows about it. They may have known about it, but just chose not to use it for whatever reason. So we can't conclude that the service is not well known and that Chris wasn't posting any leaflets. Question 30. Daniella's argument is that some sports people have superhuman reaction times because they can react to very fast serves within a limited time span, which is less than 0.25 seconds. Now we're going to weaken this argument by introducing a new piece of information that tennis players don't actually depend on this 0.25 seconds to make their move. Instead, they learn to anticipate where a serve is going to go before it's actually hit. Now, if this is the case, then this means that they actually start their return motion before they even see the ball move. So they have more than 0.25 seconds to prepare. Taking this into account, it's not necessarily true that they have superhuman reaction times where they're able to hit a ball within 0.25 seconds. They may actually have more time to prepare for the serve. And it's possible for someone with not so good reflexes or reaction time to also hit back a serve well. That's why answer option A is correct. Question 31, we've got a bit of a mathematical thinking question. All right, so people who bought 8 a.m. tickets can enter any time between 8 a.m. and 11 a.m., which is 3 hours after 8 a.m. And once they've entered, they can visit the park until either 1 hour is up or until 11 a.m. has hit. And so we can safely say that no one from this ticket bracket who bought 8 a.m. tickets is still going to be at the park at 12:30 p.m. The same thing can be said about people who bought tickets at 9 a.m. They can enter any time between 9 a.m. and 12 noon, and they can visit the park until either 1 hour is up or until 12 noon has hit. So no one from this ticket bracket is going to be in the park at 12:30 p.m. But people who bought the 10 a.m., 11 a.m. and 12 noon tickets may all visit the park at 12:30 p.m. So therefore, the greatest number of visitors that could have been in the amusement park at 12:30 p.m. is if we add all of them up. So we've got 42 plus 29 plus 31 giving us 102, which is answer option B. All right, moving on to question 32. One of the colors is red, so option D can be eliminated. That's because option D, where it says another ship nearby, that message actually flashes yellow, blue, and green, which does not include the color red as required. Now, the other three messages all include the color red. So we're going to have to use another piece of information to actually determine which of the messages Ellen actually received. All right, we know that Ellen can work out which message is conveyed just by knowing red and one other color. Now, this other color must be a really special one in that it's not present in the other two messages, which is why Ellen can work this out without any confusion in the first place. Now, it turns out that blue is this special color because it's only present in the message storm incoming, but not the other two messages, safe to dock and don't dock. So that's why answer option B is correct, storm incoming. Question 33. A constellation is a group of stars, and in ancient times, sailors used the position of the constellations to navigate on the open seas. Now, Amir says that this must mean that sailors had to hope they had clear skies at night, otherwise they'd be certain to get lost. And we're asked to find what mistake Amir actually made when making this statement. Now, Amir assumed that constellations were the only form of navigation that ancient sailors could use. He thought that if you didn't have the constellations, then there's literally no other way to be able to navigate on the open seas. Now, that's actually an incorrect assumption because it's entirely possible that the ancient sailors had other methods of navigation if they didn't have, if constellations weren't an available option. So answer option C is correct. Moving on, question 34. Option C is correct, and we've attached an image over here which explains why this is the case and the views that correspond. Question 35. There's a story written in the ancient language of Galaric, and we're going to have to translate that to English using a series of translators. No one can translate directly from Galaric to English, but you can translate from Galaric to some other languages and kind of keep translating until you get to English. Now we're given this table of translators. Each person can translate between 2 or 3 languages, and having this table, we can still kind of see that the story can't be translated to English yet. This is because there is a broken chain in the translation chain. And the question asks us, which one of the following extra translators would make it possible? So essentially an extra translator to kind of complete that translation chain. Well, first of all, I think it's appropriate to actually start off the translation chain and have a look at where we're up to so far, like without any extra translators. Well, we do know that we're going to start off with Galaric. The only translator who actually knows this ancient language is Kiara, so we're definitely going to have to use Kiara. And Kiara is going to translate from Galaric to Hindi, which is the other language she knows. Okay, with that being said, the only other translator other than Kiara who knows Hindi is Adya. So remember, we need someone who knows Hindi right now because the book's translated to Hindi and we need to translate from Hindi to something else. In this case, this something else is Italian because Adya is responsible for translating Hindi to Italian. Now, this is where the translation chain is broken because no other translator knows Italian. We need to find an extra translator who actually knows Italian. Now, straight off the bat, options B and C are incorrect because none of them know Italian. Now, it's between option A and D. Let's have a look at answer option D, why it's incorrect. Okay, so Manara can translate from Italian to Punjabi. Now, the only other translator for Punjabi is Kyra. Kyra can translate it into Greek or Wiradjuri. If translating to Greek, that's actually a dead end because there's no other translator at all who knows Greek, and this cannot in any way be translated to English. Wiradjuri, you can translate that to Bangla through Ahmed, but it is also a dead end because there's no other translator who knows Bangla and can translate that to English or any other language. Whereas let's look at answer option A, why it's correct. Let's keep following the translation chain. So Peter can translate from Italian to Vietnamese. Now the only other translator who knows Vietnamese is Diego, and Diego can do the job of translating from Vietnamese to Spanish. Finally, Diane can translate from Spanish to English. So this completes the entire chain from Galaric all the way to English. Answer option A is correct. Moving on to question 36. We've got Sally who's organizing a street party. It says that the people on the street are really busy, and unless she's able to get her invitations printed on time, then very few people will come to the party. Okay. Joy says, if there aren't many people at the party, we'll know that Sally didn't post her invitations on time. Now that's actually an incorrect assumption. Just because there's very few people at the party, it doesn't mean that that's because Sally didn't post her invitations on time. Sure, not posting invitations on time would result in very few people, but just because there's few people, you can't draw that conclusion that Sally didn't post invitations on time. There may be some other reasons as to why there were few people. For instance, a bad choice of venue or something like that. So that's why Joy is incorrect. Now Samira says that if there are a lot of people at the party, we'll know that she did post the invitations on time. And Samira is correct, yes. If Sally didn't post her invitations on time, there will definitely be very few people at the party. But since this is clearly not the case, because there are a lot of people at the party, then Sally must have posted her invitations on time. So Joy's incorrect, Samira's correct. Answer option B is what we're going to go with here. Question 37, a fairly easier question where we're just going to read off the table and see who's fastest at swimming, cycling, and running. Turns out that Grace is the fastest swimmer at 5.6 minutes. Caleb is the fastest cyclist at 24.1 minutes. And the fastest runner is Eli, who runs 12.0 minutes. So therefore, the total time taken for the team of 3 to complete the course will actually be, if we add it up, 5.6 plus 24.1 plus 12.0 gives us 41.7 minutes, which is answer option A. All right, question 38. So Tricia's trying to decode this message, and she thinks that the first word might mean the, probably because there's only 3 letters, SFB, and the only has 3 letters. Now Tricia's run into a problem. Tricia says that would mean that the letter E only appears once in the message, which would be unusual because E is a very common letter. Now, which one of the following mistakes did Tricia make? So the mistake that Tricia actually made was that she assigned the code letter B to the letter E in our language. And she thought that since there's no other B in the code, that definitely means that there's no other E. Now that's actually problematic because no one actually said that each code letter corresponds to exactly one translated letter. Like, we're not given this piece of information, so we can't make that assumption. Letters in the message might not always be represented by the same letters. So for instance, what if we had a code rule that tells us to shift every second letter 1 forwards and shift every other code 1 backwards? So this is one of the cases that is entirely possible. I'm not saying that it's correct and it will result in a good code, so which it does not, but it's an example of what might happen, that why Tricia can't draw the conclusion that that each code letter corresponds to one translated letter. So this is why answer option D is correct. Nearly there. Question 39. The girls, okay, this is one of the curveball questions, or rather difficult deduction questions. There are essentially many different possibilities for the 2 pairs of sisters, but in each of these possibilities, one pair always remains unchanged. So no matter what possibility you think of, no matter what scenario you think of that's correct, there's always going to be this one pair who remain as sisters. Now, there's 2 ways we can go about solving this, either by trial and error or by proof by contradiction. Now, the latter one, proof by contradiction, is a bit more elegant and complete, but it could be harder to think of, which is why we're going to go with the first solution, trial and error, for now, and we'll talk about proof by contradiction a bit later. So the first solution, straight off the bat, we can eliminate answer option B because Alinta and Janali are next to each other on the first photo. This breaks the rule of sisters not standing next to each other. So clearly Alinta and Janali are not sisters. Using the same reasoning, we can also eliminate answer option C because Madika and Janali are next to each other on the second photo. Again, they're not going to be sisters because they're standing next to each other. Now we'll try to eliminate answer option A by thinking of a scenario where Alinta and Shakira are not sisters, yet the conditions of the question are satisfied. So one such scenario is if Madika and Clara are sisters and Shakira and Janali are sisters. So this scenario is correct, and it shows us that Alinta and Shakira don't necessarily have to be sisters. This is why answer option D is correct. It's the only remaining one. Now, in this trial and error kind of approach to the question, it's actually very hard to straight up prove why this combination, Madika and Clara, are definitely sisters. This is actually something we'll do formally through proof by contradiction, which is the next thing that we'll talk about. So moving on to proof by contradiction, that means we're going to assume an option is incorrect. Then we're going to draw a series of conclusions until a contradiction is reached, which we'll use to prove that the original option is actually correct, because otherwise, if it's incorrect, there's going to be contradiction, which we don't want. So let's assume that option D is incorrect. If option D is incorrect, then Madika and Clara are not sisters. So remember, we're assuming that this is true, that Madika and Clara are not sisters. Now, in the first photo, Madika is next to Alinta and Shakira. So Madika is not sisters with those two people either, because remember that sisters cannot stand next to one another. So Madika is not sisters with Alinta, Shakira, or Clara. Now, the only other remaining person for Madika to be sisters with is Janali. However, on the second photo, Madika is next to Janali, which breaks the rule of sisters not standing next to each other. Now, this is a complete contradiction. We might find that there's one other case where Madika isn't a sister at all to anyone, but this is definitely also a contradiction. Because let's take a look at what happens if Madika is not a sister to anyone. Well, the other four people must be sisters. Now, Janali is next to Alinta in the first photo, so Janali is definitely not going to be sisters with Alinta. There's only two other possibilities. So Janali is sisters with Shakira, in which case Alinta is paired with Clara. Now that's a contradiction because in the second photo, Alinta is next to Clara, meaning they're not going to be sisters. The final possible pairing is Janali with Clara, in which case that's also a contradiction because in the second photo, Janali is right next to Clara. All right, so we can see that any type of combination results in a contradiction if Madika and Clara are not sisters. So if that is true, since that's a case where if we don't have these two people as sisters, we're always going to end up with impossible scenarios, then it follows that these two are definitely going to be sisters if we want to get correct scenarios. So Madika and Clara must be sisters. Now we've only included this proof by contradiction for extension for students who are interested in this. It's highly unlikely that the selective test is expecting this type of proof, but it seems that for this question, proof by contradiction is the only way to actually formally prove that option D is correct. Otherwise, you'd have to go through every single combination to show that Madika and Clara are always sisters, in which case you'd almost have about 60 or something different combinations to go through, which would take 3 or 4 whole pages, which is quite unrealistic. So yes, the most complete and elegant solution is proof by contradiction, but this is just for extension and for sake of completeness. Question 40. We're going to use the property that all three dice are identical. Using this property, we can rotate cube Z such that it lies in the same orientation as cube Y. Now, if we imagine it, the right side of cube Y is the same as the front face of cube Z, which has 2 dots. So the right side of cube Y also has 2 dots. Now, since pairs of opposite faces add up to 7, we can draw the conclusion that the left side of cube Y has 7 minus 2 equals 5 dots. And this is one of the hidden faces of dice X and dice Y that are touching each other face to face that we're actually required to find. Similarly, we can apply this whole kind of process except for cube X. So we're going to rotate cube Z such that it lies in the same orientation as cube X. Now the left side of cube X is the one that we know. It's the same as the top face of cube Z, which has 3 dots. So it follows that the left side of cube X also has 3 dots. Now again, since pairs of opposite faces add up to 7, the right side of cube X has 7 minus 3, which gives us 4 dots. Now this is the other hidden face that we're required to find. Therefore, the sum of the two hidden faces is 5 plus 4, which equals 9, giving us answer option D. Thank you for listening. We hope you enjoyed and I hope this was helpful.